Climate change, the single biggest threat to all life on Earth, is a problem that stems from the massive amounts of unsafe energy we use. So, we created a product that would decrease the amount of energy we use, reducing our effects on climate change. We present Project ATIS. Essentially, Project ATIS is a drone that flies around and measures the temperatures of different coloured roofs. It does this to see what colour of roof has the best thermal properties. So we began with the question, what uses the most electricity in many schools and workplace environments? And the answer to that, especially living in Australia, is air conditioners. In fact, the National Renewable Energy Laboratory stated that air conditioning is responsible for the equivalent of 1,950 million tonnes of carbon dioxide released annually. We then thought about how the roofing of a building can impact the temperature of its room. For example, if the colour or material of the roof wasn't effective at reflecting the sun's rays, the heat would be absorbed into the room, forcing the need for an aircon to be switched on, and making the aircon have to work a lot harder to reach the set temperature. Whereas an optimal roof would reflect the light and heat a lot better, keeping the room at a cooler temperature so the aircon does not have to work as hard, and would possibly result in the aircon not having to be switched on at all, both saving electricity and the environment. So, our solution is a drone that measures the temperatures of different coloured roofs to see which colours are best at reflecting the sun's heat, which stops the room from getting hot, which will ease the use of air conditioners, which will contribute to saving the environment. We will then use these results to recommend that future roofs are constructed with the best colours. It was now time to construct the device. We chose to make our drone run in an Arduino-based system. The drone would need an Arduino, an infrared non-contact temperature sensor, a small screen to display the temperature, a power source, which we used a rechargeable lithium-ion battery, and a power supply module that was created by modifying a breadboard power supply. After connecting all these parts to a large breadboard, this was the result. It worked well, but this configuration would have been far too large and heavy to mount onto the drone. So we shrunk it down by connecting everything to an integrated perf board, and this was the result. Here's a quick demonstration of the device. We held a soldering iron just below the temperature sensor, and its very hot temperature was displayed. Before the electronics finished, it was now time to create a mount to hold it onto the drone. We used the CAD software Fusion 360 to model the mount, which was then 3D printed. Then, the Arduino's code, which took a while to write, was updated and uploaded to the board. And with that, our device was finished. It was now time to get the device flying and reading different roof temperatures. When in flight, the drone's camera stays in an upwards position to see where it's going, and after it lands, the drone's camera is angled down to view the screen displaying the temperatures of the roof it's sitting on.
Oh, look at that!
16.53 degrees.
The blue roof was 16.5 degrees, and this white roof was 14 degrees. We then continued to test other roofs. We ran tests in the morning sun, the lunchtime sun, and the afternoon sun.
What we discovered is that in Assisi, in southeastern Queensland where it is warm most of the year, in classrooms with up to 30 people at a time, that white and cream roofs are the best, and this is shown from our testing. However, in a colder climate, a darker roof may be superior due to its effective absorption of heat, and warm up the already cold room, which reduces the load on heating devices.
This is not at all limited to simply black for heating and white for cooling. All environments are different, and all have different optimal roof colours, and this is where ATIS shines. Some buildings may be in a hot environment, but are completely shaded through some parts of the day, so may want some heat, but not too much. What colour roof should go there? Perhaps there is a factory in which machines need to operate at very precise temperatures. ATIS can find out the optimal roof colour that absorbs just the right amount of heat to assist in getting the factories to the correct operating temperatures for the machines. Another amazing use for this technology is in developing countries. People's houses may not have temperature control devices or may not have access to electricity. So by using ATIS technology, we can help them pick the right roofing, which would help to bring the temperature of their house to a good level. Another use for this device is that it can be used to get data from volcanic, thermal, or other hazardous areas.
It's all about finding the absolute perfect roof the building requires to minimize the use of heating and cooling devices. It could be red, green, blue, white, black, pink, orange, and the list goes on. I think you get the point. There are thousands of different options of roofs, only one of which can be the optimal roof for one of literally millions of different places, and it's impossible to know what's exactly right until now. Using ATIS, we now have the ability to reliably find the one optimal color by conducting real-world testing, which means that we will reduce the need for heating and cooling devices, which contributes to the stoppage of climate change.
This was Assisi Team 1's STEM Mad video, and on behalf of Assisi Catholic College, we look forward to implementing ATIS into the world and contributing to the end of climate change. Thank you.